Now, when you multiply, let's say I want to multiply 4 times 5. That's equal to what? 20. The name of this is called what? Factor. This is also called what? Factor. And the result is always called what? Not sum. Sum is for addition. Product. Thank you. Product. Again, when we get to section 6 in the book, word problem, when you hear the word product, that tells you it's a multiplications. Now, so we write 4 times 5 equals 20. That's how I write that. Some people will write that 4.5. The dot means multiply. 4 times 5, that's equal 20. Some people will write that 4 times 5, like this, parentheses they put them. That also means multiplication. So all three of them, when you see that, it means multiply. And I mix and match. I don't have really any preference. So how do we multiply numbers? And we'll look at some of the rules for multiplication. So the first rule we're going to look at, it's called the identity property of multiplications. Let's look at that. What is 5 times 1? 5. What's 8 times 1? Any number multiplied by 1, it's always the number itself. This is called the identity. The identity property of multiplication. A number multiplied by 1 is the number itself. What about 7 times 0? What is that equal to? 0. What's 5 times 0?
0.
Any number times 0 is 0. That's called multiplication property of 0. So a number times 0 is always a 0. Now, if you remember with the addition method, we said 2 times 3 is the same as 3 times 2. Well, we have the same thing for multiplications. 2 times 3 is the same answer as 3 times 2. If you switch them, the answer doesn't change. 5 times 4 is the same as 4 times 5. So if you flip-flop them, it's not going to change your answer. That's cumulative property of multiplications. I guess I'm loud there. So switch, if you multiply numbers, if you switch the order of them, it's really not important. Again, this becomes not big, but we use that a lot down in the course. X times 2, I make that 2x. So how'd you change it to 2x? Because x times 2, I can rewrite that when you have x times 2, and I can make it 2 times x. And a lot of times we don't put the dot between them, it becomes 2x. 2x means 2 times x. So you'll see me use that rule a lot down the road. And the last one I'm going to mention here, well, maybe 2 more. Associative property. That's when you have 3 numbers you want to multiply. 2 times 3 times 4. Notice I rewrite that in the same order. The first one says if you group the first 2, take the result multiplied by the third number, you end up with the same answer. If you multiply the last 2 first, take the answer multiplied by the first.
Yeah.
That is associative property of multiplications. Did anyone do section 1.2, the homework? Anyone? Were there a lot of these names on it? Was any of the questions about the name of the property? No? You're probably not gonna, if you didn't see them for addition, you're probably not gonna see them for multiplication. So what this one is telling you, if you were to multiply three numbers, it doesn't matter which two numbers you multiply first. I can say 2 times 3, which is what? 6. Take the result, multiply it by 4. What's 6 times 4? 24. Or I can multiply the last two numbers first. What's 3 times 4? 12. 12 times 2, which is what? 24. Your answer is not going to change. I could even multiply the first with the last. What's 2 times 4? 8. Multiply the result by 3. 24. So which two you multiply first, not important. And the last property you're going to see there, I'll push it up there in case you're still writing. If you have 2 times 5 minus 3, you can write that 2 times 5 minus, doesn't matter if it's really plus or minus. If it's plus, you make it a plus. If it's minus, you make it a minus. So it doesn't matter what that sign there. And since I changed it to a plus, I got to change this to plus. 2 times 3. That's called distributive property. What's 2 times 5? 10. What's 2 times 3? 6. Add them. What do you have? Now, soon enough we're going to do the order of operations. That's next class. Order of operations says you got to do what's inside the parentheses first. What's 5 plus 3? 8. So to do it this way, it's 2 times 8. What's 2 times 8? Notice your answer is the same. You can distribute that. Where we use this a lot, again, algebra 1, we use this really a lot when you have a problem like this. 3 times x plus 2, and you want to simplify that. You go, that's 3 times x plus 3 times 2, which is what? 6. So we do that in one step. Distribute that one. If I have 4 times y minus 8, this becomes 4 times y, which is what? 4y. Here's the minus. What's 4 times 8? 32. So you can write that like that. Again, we'll see lots of this in Algebra 1. I just want to show you why I'm looking at this today, because we'll be using it. Did this on the homework?
No, I didn't. I didn't know how to do the homework.
Oh, okay. We'll talk about that. Yep, we'll do that. Yep. So let's multiply numbers, and I'll give you some examples where you multiply numbers and all that. I think I might even have it on my phone. Every day I get something from Priceline, a cruise. This time of the year, cruise said, you know, you can get a cruise for $100 a night for 2 people, or $80 a night for 2 people. So let's say this is $89 a night, per night. This is a cruise. And if you want to go for 7 nights, how much that cruise is going to run you? You go, what is 89 times 7? That's the multiplications. Yep. 7 times 9 is what? 63. 3 carry 6. Notice how I multiply. I line them up. 7 times 8. 56, is it? 56 plus 6?
Yeah.
What's 56 plus 6? 62. You do not Want to use a calculator for these, because for the first 6 sections you will not be allowed on the test to use the calculator. So if you practice on the calculator, when you get to the exam, it's not going to work out. The whole idea to teach you how to multiply and divide. So if you're going to use the calculator, why are we covering it then? Just push the button, you know? So that's how much the cruise will run you. Well, the cruise leaves out of Miami. Now you need a flight from New York to Miami, or Boston to Miami. Well, let's look and see. Oh, Southwest flies to Miami from Boston. Let's say the flight is $243 a person. There's 2 of you going, because this is the price for 2. There's 2 of you going. So how much the flight? You multiply that by 2. 2 times 3? 6. 2 times 4? 8. 2 times 2? 4. So this is for the flight, that's for the cruise. So what are you paying? How much are you going to pay then?
Add them, right?
Yep. 623 plus 486.
1,000.
Well, line them up. The last section of our book is the application. So notice I'm starting to bring application already right now. 3 and 6, which is what?
Is it 1,000?
9, 2 and 8, 10. 1 and 6, 7, 4, 11. $1,109 for 2 people to fly from Boston to Miami. I didn't give you a price of a taxi from Miami airport to the cruise ship, but that's separate. Then go on the cruise there, you know. Let's do more multiplications. So I'm going to multiply numbers. So we deal with multiplications all the time. Let's say I want to multiply 513, and I want to multiply that by 211. Here we go. 5, 1, 3, 2, 1, 1. One times 3. We start from the right side. What's 1 times 3? 3. 1 times 1. 1 times 5. 5. Now we grab this one. 1 times 3. 1 times 1. 1 times 5. The next one. 2 times 3. Notice where I put the 6 under the 2. 2 times 1. Try again. 2 times 5. 10. And now you add them. 3 plus nothing. 1 and 3. 5 and 1. 6 and 6. 12. 1 and 5. 6. 6 and 2. 8. 0. 1. So the answer is 108,243. The problem I say, find the product. Of 987 and 208. That's what the question is going to say. So what does that mean? Does that mean add them? Subtract them? What do you do?
Something that.
What is product? Product means what?
Something they both go with.
Multiply.
I was wrong.
So that's why I said know the name, because you might see a question like this. So product means multiply. 987 times 208. 8 times 7, 56. 8 times 8, 64. 64 and 5, 69. 9 carry 6. 8 times 9,
72.
72 and 6.
78.
72 and 6 is 78, yep. Now we grab the 0. I'll clean this out. What's 0 times 7? 0. 0 times 8? 0. 0 times 9? 0. Now the 2. That's the third digit. 2 times 7? 4 carry 1. 2 times 8? 16 and 1? 17. 7 carry 1. 2 times 9?
18.
And 1?
19.
19. 6, 9, 8 and 4, which is what? 12. Oh, I almost wrote 12 here. 12. That's 2. Carry 1. 1 and 7. 8 and 0. 8. 8 and 7, 15. 5. Carry 1. 1 and 9. 10. 0. Carry 1. 1 and 1. 2. 205, 296. Again, just few examples where we use that. Let's say your parents want to put a fence around the house, or they got a pool. We'll do a pool here. Here's the pool. The pool is 32 by 16. So they went 4 feet behind that. That's 4 feet here. 4 feet in this direction, all these directions. 4 feet in this direction. Because they want to pour concrete around that so you can walk around the pool. And now they're going to put a fence. Here's my fence. I'll make a different color fence, thick one. You're going to put a fence on the outside. The first question I have is, how many feet of fencing do we need? How much fence?
Well, you have to know.
Well, how long is this piece?
4.
From here to there.
No, it's
What is the length?
From here to here. What's that distance?
8.
8.
I don't know. 4.
It's not a guessing game. 4 be in the middle of the pool. It's going to go on the outside of the pool. It has to be more than 32.
oh,
The pool is 32 by 16.
it's 40.
Remember, the pool is 32 here, 16 here.
It's 40, right?
Well, it's 32 from here to there. Add 4 to this end, add 4 to that end. Because the fence got to go 4 beyond and 4 beyond. So 32 is this distance. Add the 4 here and add the 4 here. That's 40. If this side is 40, then this side is 40. There's another 40. So this has to be 40 now. This has to be 40. What's the width here?
24.
From here to there is 16. Add the 4 here and add the 4 there.
Okay, I get it now.
24 here, 24 here. So how many feet of fencing do we need? Add them. Let's see, 40, 40,
80.
24, 24, 4 and 4, 8. 4 and 4, 8, 10, 12. 128 feet of fencing. Now we get in the car, the truck, and we drive to Home Depot or Lowe's to buy the fence. And the fence is selling at a price $15 a foot. It's a nice fence. For every foot, you're going to pay 15 cents. That's the price. So how much going to cost you to buy that fence? It's going to be 128 feet times the $15 per foot. I didn't deal with the post and the gate and all that. So let's multiply. Five times 8, 40. 5 times 2, 10 and 4, 14. 5 times 1 is 5 and 1 is 6. 1 times 8. 1 times 2. And 1 times 1, 1. 0. 4 and 8 is what? 12. 2 carry 1. 1 and 6 is what? 7 and 2, 9. So it's going to run you $1,920 for that fence. As I said, this is an expensive fence. It's $15 a foot. Not the 8 section, the 8-foot section.
That's a lot of money.
So $1,920 for that fence there. So this is where some of the application for multiplication, division, addition, subtractions that you see. I'll do another example on this, just where we use it. Kitchen. Some of you might have a countertop. It looks like this. You have a sink here. This is the sink. And the countertop goes like this.
Doesn't everybody have that?
No?
Oh, okay. No, I don't have that.
There's a kitchen. Let's say the dimension is 39 inches here, this side. This is 25 inches, that piece. This piece is 82 inches. The width 25 inches for all of them.
Yeah, what's the top you can?
And let's say 160. Now the sink. I don't know what the dimension of a sink. Anyone? Sink is what, 30 by 20 inches? I don't know. And I need to find out the area of that surface. Because if you were to call a place that will do like a fancy top, Korean, marbles, whatever, concrete, they'll calculate that area. They won't deduct the sink, by the way. They'll just cut it when they show up there. But I'm going to deduct that sink. Okay. Now, just to give you an idea, an area of a shape that looks like this. What is the name of this shape? If you have something that looks like this. That's rectangle. And the area of a rectangular shape, the area is always what? The length times the width. Can we find the area of this countertop?
Yes.
Well, first, let's break it down to pieces. I'm going to break it down to pieces. Here's one piece. Nope. Here's another piece. Here's the third piece. Can you see it? So I'm breaking into 3 pieces. Then I'll subtract from this piece, I'll subtract the area of that. Because there's a hole there. So what's the area of this piece? Let's call that A1. Area 1 is going to be the length times the width, which is 82 times, what's the width here? 25. So let me go to the side, 82 and 25, and multiply them. 5 times 2, 10, 0, carry 1. 5 times 8, 40, that's 41. 2 times 2, 4, 2 times 8, 16. 4 and 6, 10. That's 2050 square inches. Area always in inches squared, always.
That's the area of P1.
This piece, yes.
Okay, so
Let's call this area 2. What is area 2 then? Again, length times width. The length is what? 39. The width is what? 25. 39 times 25. 5 times 9? 45. 5 times 3? 15 and 4? 19. 2 times 9? 8, carry 1. 2 times 3, 6 and 1, 7. 9 and 8 is what? 17. 7 carry 1, 1 and 1, 2 and 7, 9. 975.
9 times 8.
Now let's call this area 3. That's before I cut the hole for the sink. I didn't cut the hole yet. Area 3 is going to be what? Length times the width. What is the length? It's not 160.
No, it's 160.
160 all the way to the end. That's all the way to here.
110.
That's the 160. So you're going to subtract from it the 25 here, and you're going to subtract the 25 here, because I already took that out. So take a 25 and take a 25, you're taking 50 from it. So this here is really 110, not 160, because you took the 25 on that end, the 25 on this end. So 110 times the 25. The width still 25. The counter has the same thickness around. This is 25. So 110 and 25. 5 times 0 is 0. 5 times 1 is 5. 5 times 1 is 5. 2 times 0 is 0. 2 times 1 is 2. 2 times 1 is 2. 2750. What about the sink?
The sink?
We're going to cut that hole. 30 times 20, which is what? 600. So what is the area of the counter now? It's going to be this piece, right? And how big that piece? That's 2050. Add to it that piece, 975. Add to it this piece, 2750. Subtract from it, there's a hole there. Subtract from it the sink, which is 600. And that's how much counter space you have. So if you go to the side and add them, you'll end up with an answer equals to 5175 inches squared.
So, we're allowed to use a calculator?
Nope, nope, we gotta do them by hand. No calculators.
So, can you show us how you did